1,000 times bigger than Earth. It's mostly gas, and it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces?
Imagine a planet so massive that it doesn't truly orbit the sun, a world with storms larger than Earth, and a magnetic field unlike anything we've ever seen. What secrets could such a planet hold? When NASA's Juno spacecraft arrived at Jupiter in 2016, everything we thought we knew about the gas giant changed forever. Jupiter, the king of planets. For centuries, it's fascinated scientists and stargazers alike with its colossal size and swirling storms. But NASA's billion-dollar Juno mission has unveiled some of Jupiter's most mind-blowing secrets, leaving scientists baffled and eager for answers. From its mysterious auroras to its possible water-rich atmosphere, Juno's findings are reshaping our understanding of this enigmatic giant. So what exactly has Juno uncovered? And how do these discoveries challenge everything we thought we knew about our solar system? Let's dive in. Jupiter is a planet of extremes, with a mass 2.5 times greater than all the other planets combined. It's no wonder it's called the king of planets. It's over 483 million miles away from the sun, and despite taking 12 Earth years to orbit, its days are shockingly short, just under 10 hours. This rapid rotation creates powerful winds that carve its iconic cloud belts and zones, showcasing the planet's dynamic and chaotic atmosphere. When Juno arrived in 2016, its high-tech suite of instruments began peeling back Jupiter's atmospheric layers like an onion. One of the most startling discoveries was how far down the planet's colorful belts and zones extend, over 1,900 miles beneath the surface. And while Jupiter's famous Great Red Spot has been studied for centuries, Juno revealed it contains more water than scientists ever imagined, potentially holding clues about the planet's mysterious weather patterns. Another jaw-dropping discovery: Jupiter doesn't orbit the sun like other planets. Its immense gravitational pull causes the sun itself to wobble, as both Jupiter and the sun orbit a common gravitational point known as the barycenter. This phenomenon highlights just how massive and influential Jupiter truly is. And then there are the auroras, breathtaking light shows caused by the planet's magnetic field. Unlike Earth's auroras, which are powered by solar winds, Jupiter's are fueled by its own plasma field. Juno found that these auroras are up to 30 times more energetic than expected, glowing primarily in ultraviolet light invisible to the human eye. What's causing this mysterious force? Scientists are still searching for answers. Jupiter's moons are just as fascinating. Its volcanic moon Io, for instance, boasts over 150 active volcanoes. But Juno's infrared cameras recently detected what could be a brand new volcano on its surface, further proving how dynamic and unpredictable this moon truly is. Juno also captured high-resolution images of Jupiter's poles, areas never seen before. These poles are home to symmetrical clusters of massive storms, unlike anything on Earth. The detailed 3D models created from Juno's infrared images showed us that these storms are far more complex than scientists ever imagined. And if that weren't enough, Jupiter has its own ring system. While Saturn's majestic and easily visible rings often steal the spotlight, Jupiter's ring system is a subtle yet fascinating feature that underscores the gas giant's complexity. First discovered by the Voyager 1 spacecraft in 1979, Jupiter's rings are faint and composed primarily of microscopic dust particles. These rings are not as grandiose or as easily observed as Saturn's icy bands, but they hold unique scientific value and offer intriguing insights into the processes shaping Jupiter's dynamic environment. Jupiter's rings are divided into three main components: the halo ring, the main ring, and the gossamer rings. The halo ring, the innermost section, is a thick torus of fine dust particles that appear diffuse and faint, almost blending into the planet's background. The main ring is the most prominent of the three and is relatively narrow and flat compared to Saturn's iconic rings. Beyond the main ring are the gossamer rings, which are even fainter and extend farther from the planet. These outer rings are named after the small moons Amalthea and Thebe, whose surfaces are continuously bombarded by meteoroids, creating a steady stream of dust that replenishes the rings. What sets Jupiter's rings apart from Saturn's is their composition. Unlike Saturn's rings, which are primarily made of ice particles that reflect sunlight and make them brilliantly visible, Jupiter's rings consist mainly of dark, microscopic dust grains. This dust is likely derived from impacts on Jupiter's small inner moons, such as Adrastea and Metis. When meteoroids collide with these moons, the resulting debris is ejected into space and becomes trapped in Jupiter's gravitational pull, forming the thin, dusty rings we observe. The faintness of Jupiter's rings makes them difficult to study from Earth. They are best observed using advanced instruments aboard spacecraft, such as NASA's Juno mission, which continues to provide unprecedented data on the planet and its rings. The discoveries made by Juno are a testament to the power of human curiosity and exploration. But there's still so much more to learn. What other secrets is Jupiter hiding in its swirling storms and dazzling auroras? Thanks for watching. If you enjoyed this deep dive into Jupiter's mysteries, don't forget to like, subscribe, and hit that notification bell for more cosmic content. And while you're here, check out the video on your screen for more incredible discoveries about our universe. See you in the next adventure. Pluto, once dismissed as a frozen wasteland on the edge of our solar system, is turning out to be a cosmic enigma that challenges everything we thought we knew. But what exactly has the James Webb Space Telescope uncovered about this mysterious dwarf planet? Today, we dive into the groundbreaking discoveries made by the James Webb Space Telescope about Pluto, a world that might not be as cold and lifeless as we once believed. From hidden oceans to potential signs of life, Pluto's story has just taken an astonishing turn. For decades, Pluto has fascinated scientists and the public alike. Once the 9th planet of our solar system, it was demoted to a dwarf planet in 2006. But despite its status change, it remains a subject of intense interest. NASA's New Horizons spacecraft, which flew by Pluto in 2015, unveiled its icy terrain and hinted at more secrets beneath the surface. Now the James Webb Space Telescope has taken that exploration to a whole new level. Using its powerful infrared capabilities, James Webb has pierced through Pluto's frozen atmosphere to reveal astonishing details. One of its most groundbreaking discoveries: Pluto may harbor a subsurface ocean beneath its icy crust. This finding reshapes our understanding of where life could potentially exist in the universe. Liquid water, one of the key ingredients for life, might be hiding deep beneath Pluto's surface, kept warm by heat generated in its core. But that's not all. Webb has detected evidence of cryovolcanism, volcanoes that erupt with ice instead of lava. These icy eruptions suggest that Pluto is far from geologically dead. Instead, it appears to be a dynamic world, with forces shaping its surface even now. The surprises extend to Pluto's atmosphere. Unlike the thin, static atmosphere once imagined, Webb's observations reveal a highly dynamic system. As Pluto orbits the Sun in its elongated path, its atmosphere sublimates, vaporizing when closer to the Sun and freezing back onto the surface when farther away. Webb has even detected unexpected organic compounds in the atmosphere. Could these complex molecules be hints of chemical processes akin to those that led to life on Earth? Even Pluto's largest moon, Charon, is proving to be more fascinating than we thought. Webb's data shows signs of tectonic activity on Charon, with massive cracks and canyons suggesting possible subsurface heating. This raises the tantalizing question: could Charon too harbor an underground ocean? Pluto's smaller moons present a fascinating puzzle that astronomers are only beginning to unravel. Unlike the more predictable orbits of larger moons around their host planets, these smaller moons, Nix, Hydra, Kerberos, and Styx, exhibit chaotic and irregular paths, almost as if they are tumbling through space. Their unpredictable orbits have baffled scientists for years and raised profound questions about the forces at play in this distant region of our solar system. These irregular motions point to complex gravitational interactions, not only between Pluto and its largest moon, Charon, but also among the smaller moons themselves. By studying these interactions, scientists hope to gain a deeper understanding of the dynamics of planetary systems and uncover secrets about the early solar system's chaotic and formative years. Pluto and its moons are thought to be remnants of the Kuiper Belt, a vast region of icy bodies left over from the formation of the solar system. The Kuiper Belt is often described as a frozen relic, a time capsule that preserves the conditions and materials from the early days of our cosmic neighborhood. Within this context, the study of Pluto's moons takes on greater significance. These small moons, with their strange orbits, could serve as keys to unlocking the mysteries of how the solar system came to be. Scientists theorize that the chaotic orbits of Pluto's moons are a result of past events, such as collisions, gravitational disruptions, or even interactions with other Kuiper Belt objects. Understanding these events could provide insights into the violent processes that shape not only Pluto and its moons, but also the larger structure of the solar system. One of the most intriguing aspects of Pluto's smaller moons is how they challenge traditional assumptions about celestial mechanics. For instance, Nix and Hydra are locked in what scientists call a spin chaos, meaning their rotations are highly irregular and unpredictable. This chaos is believed to be caused by the gravitational influence of Pluto and Charon, which exert a kind of tug-of-war on the smaller moons. The resulting instability makes it nearly impossible to predict the exact orientation of these moons at any given time. By studying this behavior, astronomers can better understand how gravitational forces interact in multi-body systems, a topic that has implications for studying exoplanetary systems and other celestial phenomena. Moreover, the composition and surface features of these moons offer additional clues about their origins. Observations suggest that the smaller moons are made of water ice and other frozen materials, similar to what is found on Pluto and Charon. This compositional similarity supports the idea that Pluto and its moons share a common origin, likely forming from a massive collision that occurred billions of years ago. Such an event could have ejected debris into space, which later coalesced into the moons we see today. This theory aligns with the giant impact hypothesis, a model that has also been used to explain the formation of Earth's moon. If confirmed, the study of Pluto's moons could provide a broader framework for understanding how moons form in planetary systems across the universe. The irregularities in the orbits of Pluto's smaller moons are not just scientific curiosities. They also serve as natural experiments for testing theories about the dynamics of planetary systems. By analyzing how these moons interact with each other and with Pluto and Charon, scientists can refine their models of orbital mechanics. These insights are not limited to our solar system, but can also be applied to the study of exoplanets and their moons, particularly in systems where gravitational interactions are similarly complex. Pluto is no longer just a forgotten icy rock at the edge of the solar system. Thanks to the James Webb Space Telescope, it's now a dynamic, complex world that may hold clues to life beyond Earth. These discoveries challenge our understanding of habitability and open the door to exploring other icy bodies in the cosmos. Who knows what other secrets await? If you enjoyed this deep dive into the mysteries of Pluto, be sure to like, subscribe, and hit the bell icon for more cosmic explorations from our channel. Until next time, keep your eyes on the stars, because the universe is full of surprises,